So this is a follow-up video to my Coulomb's law video on electromagnetism. I'm going to do two examples here, and yeah, so let's just jump into it. First example, it says, okay, and a good technique whenever you're reading a problem is to write down your information given as you're reading it, and then read it again afterwards. But alright, so we have point charges of 1 microcoulomb and -2 microcoulombs are located at 3, 2, -1 and -1, -1, 4 respectively. So let's write what we got down in our first sentence. We have two charges. We have Q1 equals 1 microcoulomb, and then we have Q2 equals -2 microcoulomb, and Q1 is located at 3, 2, -1, and Q2 is located at -1, -1, oops, not n, -1, -1, 4. So the problem goes on to read, calculate the electric field on a 10 nanocoulomb charge located at 031 and the electric field intensity at that point. So we have a third charge, Q3, which equals 10 nanocoulombs, and it is located at 031. So how are we going to approach this problem? This is going to be, well, let's think about this. We have 3 charges, and if you remember in my last video I talked about superposition. I said that we would focus on one charge and then take into account all the charges around that charge. So in this problem we're focusing on charge 3 right here, and we're finding the electric force on this charge as well as the electric field intensity on this charge. So let's just write down our force equation. That's going to be some K is going to run from 1 to 2 because we have 2 charges here. So there's going to be, well, 2 other charges besides this one we're focusing on. That's going to be contributing. It's going to be Q of the charge we have times Q of the charges around it, and then the of course the 4 pi. Where's epsilon? Epsilon 0. We talked about what epsilon was in the last video, times r squared, and then oops, a sub r, where a sub r is a unit vector of capital R. Okay, so this is going to translate into, well, right away let me just do one extra step to show this. We can basically we can factor out everything from this except for Q sub k. Well, except for r and r squared, because r squared is gonna differ, and you'll see why in a moment when I expand r squared, so to say. So in the last video we talked about what a sub r was, and how you can rewrite this expression here as the following. This is going to be r minus r sub k, and then magnitude, where's my magnitude? There it is. R sub k cubed. Now if you don't know why that's cubed, or if you don't know what went on here, watch my previous video. I'll put it in the description so you can see it. It says Coulomb's law. So That's why we couldn't factor out this r squared, because it actually has this counting mechanism k inside of it. So we'll just use this formula here to find the fourth. So the fourth is going to be equal to, well, you keep this factored out, and it's going to be, well, q sub 1. Actually, we'll write it out explicitly so we can show each step here. Then we got minus r sub 1. Oops. And then this is 1. So I feel like this is more instructive for some people who might not be used to doing this type of thing. Alright, so we went through the summation when k equals 1 and 2, and these are the expressions we got. So now all we need to do is plug in. I'm just going to make a new line. So we're just going to plug in here. We have to, well, okay, so let me look at my notes here. We need to find, well, let's plug in our vectors. So we have 0, 3, 1. That's right here. That's this guy. That's going to be our first. That's going to be this r right here. From the geometry we went over in the previous video. So it's going to be. I'm going to write with the vector brackets. Vector brackets. Where are you? There you are. 0. Let me copy these vector brackets. There we go. So 0, 3, 1. Minus. Now, what's our r1? It's 3, 2, negative 1.